Hello everyone, this is the part 5 of Unit 5. In this video, we will study about distributed commit, types of commits, recovery approaches, naive snapshot algorithms, and review of some past questions. Distributed commit. The goal of distributed commit is that either all the members of group decides to perform the operation or none of them will perform the operation. A transaction that happens completely or not at all is the atomic transaction. In distributed transactions, distributed commit is required. Types of atomic commit protocols. There are three different types of commit protocols. They are one-phase commit protocols, two-phase commit, and three-phase commit. We will study these different type of commit one by one. First one is one-phase commit. In one-phase commit, maximum one-way message transmission is possible. Here, one side is designed as a coordinator. An elected coordinator tells all the other processes to perform the operation in a question. But what if a process cannot perform the operation? There is no way to tell the coordinator. In one phase commit, there is only one way message transmission. Only coordinator will ask to perform the operation. Hence, one phase commit protocols cannot be used in distributed system. The solution is that we have two others commits protocols. They are two-phase commit and three-phase commit protocols. For example, if there is a one coordinator and two other processes, and if P1 is working on some other process and P2 is ready to process, when the coordinator asks to update the variable, then only P2 is ready. So no process can happen in this case. As the goal of distributed commit is that either all the member of group decides to perform the operation or none of them perform the operation. So here P1 is not performing the operation, only P2 is ready to perform the operation. So no process will happen in this case. Two-phase commit protocol. In a two-phase commit, two-way message is possible. One coordinator is responsible for initiating the protocols. Other entities are called participants. If coordinator or participants unable to commit, all part of transactions are aborted. Steps of two-phase commit protocols. At first, the coordinator sends a vote request message to all the participants in the system. When a participant receives a vote request message, it returns either a vote commit message to the coordinator telling that it is prepared locally to commit its part of the transaction, or otherwise a vote abort message will be sent. Once all the votes are received, if all agree for the commit, global commit is done, otherwise global abort is done, and this message will be sent to all the participants. Based on the sender, they can act either commit or abort. Here is the state of two-phase commit protocols. Here is two different states. One is for coordinator and another one is for participants. At first, in coordinator, it will send a vote request message to all the participants and it will wait for the response of the participants. And in participants, after receiving the vote request message from the coordinator, it will ask for all the other participants. If one of the participants is busy in other process, then it will abort the vote request. Then it will abort the vote request. Otherwise, it is ready to vote commit. If one of its participants sends abort, then it will be global abort. Otherwise, global commit. And in coordinator, it receives the message, and if it receives a global abort, then it will abort the transactions, and if it receives the global commit, then the coordinator will do commit. And this is the working mechanism of two-phase commit protocols. In two-phase commit protocols, there is one problem. If the coordinator crashes, the group members may not be able to reach a final decision, and then may be therefore blocked until the coordinator recovers. Due to this reason, two-phase commit is known as blocking commit protocol. Hence, the solution is three-phase commit protocol. Now, three-phase commit protocol. A three-phase commit protocol is a non-blocking commit protocol. The states of the coordinator and each participant satisfy the following two conditions in three-phase commit protocol. There is no other state from which a transaction can be made to either commit or abort, and there is no other states where it is not possible to make a final decision and from which transactions are made to commit. In three-phase commit protocols, a modification is done in the two-phase commit protocols. one more state is added in between wait or ready and commit state, which is known as ready to commit. As one more state is added in the two-phase commit protocols, so it is named as three-phase commit protocol. This is the state diagram of three-phase commit protocols. This is also same as two-phase commit protocol states, but the only difference is that here one more state is added in between wait and commit, that is pre-commit on coordinator, and in participants there is one more state in between ready and commit, that is pre-commit. This is the working mechanism of three-phase commit protocols. Recovery approach. Once a failure has occurred, it is essential that the process where the failure happened recovers to the correct state. Recovery from an error is the fundamental to the fault tolerance. There are two types of recovery. They are backward recovery and forward recovery. At first, backward recovery. In backward recovery, the main issue is to bring the system from its present incorrect state back to its previously correct state. It will be necessary to record the system's state from time to time and to restore such a recorded state when things go wrong. This is done by using the checkpoints. Checkpointing can be very expensive, especially when errors are very rare. Despite the cost, it is very easy to implement and most oftenly used. Now, second one is forward recovery. Bring the systems into a correct state from which it can then continue to execute. In the forward recovery, when the system has entered into the incorrect state, instead of moving back to the previous state, an attempt is made to bring the system in a correct new state from which it can continue to execute. The main problem with forward error recovery is that it has to be known in advance which error may occur. Only in that case it is possible to correct those errors and move to a new state. Now, naive snapshot algorithm. A distributed snapshot algorithm captures a consistent global state of a distributed system. A global state can be described by a code that indicates the time at which each process checkpoints its state and the message. Snapshot algorithms records a set of process and channel states such that the combination is a consistent global state. Here is the diagram. One is for consistent cut and another one is for inconsistent cut. In the case of consistent cut, that means this one, if a message crosses C, its send should be before C and its receive should be after C. When the system is recovered from the consistent cut, every message will be sent exactly once. Here is the diagram of consistent cut. Here, this is the consistent cut and this is the message 3. The message M3 should be sent before C and received should be after C. When the system is recovered from the consistent cut, every message will be sent exactly once. This message M3 will be sent exactly once. And if a message sent is after C while its receive is before C, C becomes inconsistent. This is the inconsistency. It will cause a problem when processes are restarted from a inconsistent cut. For example, message M2 can be executed twice, that is in figure B. Here, message M2 is sent before consistent cut and it will be received before consistent cut. So that message M2 can be executed twice. The snapshot algorithm assumes that there is no network failure. Each process communicates with other process using unidirectional point-to-point channel. There is no message reordering on each channel. There is a communication path between any two processes. Any process can initiate the algorithm by using following 2 points. Checkpointing its local states, which contains all the information to reset itself, and sending a marker on every outgoing channel. Then, for every message from every incoming channel, the process writes a copy to disk until a subsequent marker is received. A process finishes when it receives a marker on each incoming channel. It finally collects states of all channels and sends them with its local states to the initiator or sender. This is the snapshot algorithm. Here are the exam questions. From next video we will start unit 6.